going to be looking at using the sides in proportion to figure out what the sides QS. So we want to find right QS and M. This should be an N. You know when my N went M. All right. Tiamo says, "Man, sounds excited to see me. I'm so excited to see you today." Yes, Tiamo. Of all the Tiamos, I know you're my favorite Tiamo. I'm gonna let you know on a secret. You're the only Tiamo I know. That's why you're my favorite.
Hello, beautiful names, like unique. I've never heard it before.
So I think it's Venda. I
wonder what it means. Like
Hi, Shaden. Oh, wow. I know, Amelia, you've also been gone for a while, so it's so great to see you again.
Oh,
you know, all right. Okay, hi, everybody. All right, let's have a look at this question on the screen, guys. Remember when we've been told that something is in proportion or that it is similar, we know that some of the sides are already in proportion. Hi, I'm on its way. All right, so the first thing we're going to know, guys, is that MN is in proportion to QR. So we can rewrite it as a ratio. Okay, MN over QR is the same as the ratio of, okay, that's the same as the ratio of NO to RS. We can use that. That's the same as NO ratio NO RS, which is also the same as, first and last, MO is the same as the ratio of QS. Oh, Palisa, hello, Palisa. I feel like I haven't seen you guys in a really long. It's literally only been 4 days.
Yeah,
but I feel like
we're also going on a holiday. We're not doing.
I know. No, it doesn't feel right. It doesn't feel right. All right, guys. All right. So we're going to leverage these ratios that we've got here, the sides and proportion, to figure out the side of QS and MN. And if anybody has any suggestions on which ones we can use in order to find, let's start with QS. Can we start with QS? Yes, let's start with QS. Which one are we going to use to find QS? I already know that I'm going to need QS and MO in order to find QS. Which other two proportions am I going to need, guys? Between MN and QR and NO and RS, which one can I use to find the side that I'm looking for? What do you guys think? Anybody got any idea? And if you're joining us for the first time, I know what's happening on the screen right now. You might be like, give it a second. We're going to get there. We'll do all the intros in just a bit. All right. Anybody got any idea? Hello, Unati. Unati's already giving that face like, hi, ma'am. What's going on? What's going on? So it's not that deep. We are just trying to figure out what the size of QS is going to be. Nicole says, please repeat the question, ma'am. Yes. All right. We're trying to find the side QS, Nicole. We're trying to find QS, which is why I'm already highlighting that we're going to have to use MO over QS to find that side. Now, let's say, for instance, I'm going to call my QS side X. Which other two ratios can I use? Am I going to use this one or am I going to use this one in order to find QS? Which one of these two proportions are going to give me the most information? I know, Nolwazi. Hi, Nolwazi. I'm going to explain to everybody what happened in just a bit, Nolwazi. I'm so sorry. We're going to speak today. Okay, we're going to have a chat today. Okay. All right. For the sake of time, I'm going to give this one to you because I feel like a lot of you guys are confused. All right. I have the side NO and I have the side RS. So I'm definitely going to use NO and RS to figure out what the side Q is. All right. So let's see what we've got here. My NO is 12 over RS, which is 30, is equal to MO, which is 15, over QS, which is. All right. What is my next step? I'm hoping everybody knows what my next step here is. What do I do next? We spoke about this in Wednesday's lesson. No worries, Kumakoko. Hello, it's lovely to see you. That's it. Yes, Puseletso. Hello, Puseletso. Okay, we're going to cross multiply. So we're going to go 12 times x is going to give us 12x. And that is equal to 15 times 3, which should give us 450. Okay, 15 times 30, sorry, not times 3. Okay, yes, we're going to cross multiply Sinuguse. That's a really clever relay. Patience can't hear me. And in case she didn't tell us, she can't hear me. So maybe let's help her. Hi, Bossy. But it was like, Christian, where is my cat? I'm not 100% sure where your cat is. You're gonna have to tell us where your cat is. Obviously, talking about Jasmine's cat, and I don't think Jasmine is with us too. Hello, CP. All right, guys. So I'm going to divide by 12 on both sides. And if I do, everybody grab a calculator, tell me. This is going to equal to what? Oh, teacher cat. Oh, I see. We spoke about this, but I will reiterate in just a bit when we start looking at introduction. All right, somebody grab a calculator for me. 450 divided by 12. I think if I do this in my 75 over 3. Puseletso, your 75 over 2 is correct. Tumototo and Amoretsu also gave me the correct answer. Okay, good. So I'm looking for 75 over 2 or 37.5. In this case, because we're looking for a side, then we can say 37.5. Okay, and then Ramo says, "Hi, ma'am, I'm a new learner in the class. May I please get an explanation of what's going on?" Absolutely, Ramo. I'm going to do that in the next 2 minutes. All right. So, Tomla, I see you as well. I think you are new. We are going to be introducing you guys in just a little bit. Okay. So just give me a second and then we'll get to your question. All right. Can you explain again? Yes, I can. All right. So we know that we want the sides to correspond, okay? So remember in our triangle, we have to make sure that everything in our triangle is moving at the right. All right, so if I write triangle MNO and triangle QRS, that means that MN, the first 2 letters in my first triangle, correspond with the first 2 letters in my second triangle, because they're similar. So I can then say MN is in proportion to QR. Almost like I'm writing a ratio. Remember we said that ratios is QR. You can either write a ratio like this, or you can write a ratio like this. You can write it one way or the other, but we're going to write it as a fraction because we want to compare the two. Okay. So we're going to write it as MN over QR. And that is going to equal to, and then we can look at our triangles exactly the way that they've given us. We're going to take the last 2 letters. I'm going to go NO, that's my last 2 letters, and those will correspond with the last 2 letters in my second triangle, RS. So I can then write them as a ratio. I can go NO over RS. My last step will be to take MO, the first and the last, MO. That's going to equal to MO over, and then we're going to do the same thing in the big triangle, QS. So MO over QS. All right, that's how we can tell in our triangle which sides are in correspondence. So we can even look at this. If we go MN must correspond with QR, and that's in fact correct. MN corresponds with QR. Same with over here. NO corresponds with RS. See how they're both at the bottom? And our triangle says so. NO corresponds with RS. Same over here. MO must correspond with QS. And our ratio says that MO corresponds with QS. All right. If you're still a little bit stuck on how to do this, we did have a look at it on Wednesday. So we've already got that recording up on our website. If you need to have a look at it, I do this exact example on Wednesday. All right. So now I say to you guys, calculate for QS. I want QS. So I want this side over here because it doesn't have a value. I want to know what the length of that side is. So I'm going to name it X. I'm going to name QS X for the sake of this X, for the sake of this. So then I'm gonna go, let me see. I know that I want to find QS, so I need to use this because it has QS in it. So I need it so that I can find out what QS is. Okay. Which other two sides do I have that I can use? Well, I can't use MN because MN doesn't have a value, but I can use NO and RS. So I'm going to go to the side that has NO and RS in it. So those are the two sides I'm going to use in order to find my answer. So I can go NO over RS. In fact, I don't even have to rewrite it. All I can say is I'm going to use this. I'm only going to use the NO over RS and the MO over QS. Then all I'm going to do is I'm going to replace the NOs and the RSs with the numbers. We know that NO is equal to 12. So I'm going to go to NO and I'm going to go 12 over RS, which is 30. RS 30 is equal to MO, which is 15, over QS, which I've now named. Then the last thing I can do now in order to solve for X, because we are actually solving for X, is we can I can do X times 12 will give me 12X, and 30 times 15 will give me. To solve for X, I'm just going to divide both sides by 12, divide by 12, divide by 12. 12 divided by 12 will cancel. Therefore, X will be equal to 37. Right. And we've spent a lot of time on this. We're going to leave it and come back to it. All right. With that being said, this is lesson 3 of 16. We have been speaking about similarity. We spoke in detail about how similarity comes about, the difference between that and congruency in the last lesson. So today we're going to be focusing on the proofs of similarity and how we can actually prove that something is similar. All right. So we're going to be taking our all right. There we go. So over time, we see the word prove. Prove that triangle ABC is similar to triangle ADE if BC is parallel to DE. So they've already given us some very important information. The first thing we're going to do is you're going to go onto your page and you're going to write, dot, dot. Then you're going to write in triangle, and then you're going to copy down exactly what they've given you. In triangle ADE and triangle, I'm doing it in the wrong direction. In triangle ABC, and triangle AD. Right. Now, they've given us some very important information there. They say to us that BC is parallel to DE. And those of you who've been with me since last week already, every time we see parallel, what are we thinking about, guys? What are we thinking about? Two lines that are parallel to each other, what's going to come to our mind? Especially when we're talking about similarity. Who remembers? Ah, Punzo, absolutely. Yes, that's it. Our fun angles. Our fun angles. Yes. So we're talking about corresponding angles and our co-interior angles. And we're talking about our alternate angles. So one of those is going to come into play here. Because remember, when we prove similarity, we can only prove it in two ways. We can only prove it with angle, 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 or we can prove it with sides and sides and top. Those are the only two. But by looking at my drawing, I can already tell that they haven't given us anything to do with sides and proportion. They haven't given us any of the sides. So this is definitely going to be an angle, angle, angle. All right. Yes, Kama. How are you doing, my sweetie?
I'm good, and you, ma'am?
Excellent, sweetie. What's up?
Sorry. Are we still on Euclid?
Yes, this is Euclid. We're going to start quadrilaterals as soon as we're done here. Yeah. Have I lost you? Hello? Oh no, I think I've lost Kama. Hello.
I think it's.
Yeah, I think it is a network issue. All right, Kama, when you can, let's see if I can get you to unmute, like, can you mute yourself and then unmute again, and then we'll try and have a conversation. All right. Does anybody have any clue as to where we can start? Let's start with our fun angles, and let's see where do you guys think we can start with these proofs. Anybody got any idea? Okay, yes, come.
I am so sorry. There was like load shedding just now. We were just waiting for the data to kick in.
Oh, I see, all right.
Sorry.
Okay.
I was
What-
just asking if we're on Euclid because like
these
I missed a
people-
few lessons.
Yes, so Euclidean grade 10 consists mostly of quadrilaterals, but we need to start with the
Okay.
triangles in order to understand.
Yeah.
All right, so we need the
Thank
proofs
you.
for the triangles for the proofs of the quadrilateral. Okay.
Sorry. Do we also need to memorize the rules?
For congruency, yes. Okay.
Okay.
All right.
Thank you so much.
No worries. All right, guys. So first thing we can do is we'll notice that these two things over here, like this, these two lines are parallel, and this creates an upside down letter. Have you guys figured out what this letter is over here? You're right, Kimokoko, they are parallel. They told us that BC and DE are parallel. But that tells me something about the angles. Which two angles are we looking about? Yes, that's a so yes, it's an upside down end. Good. Which means we're gonna have corresponding angles. Two angles are corresponding, guys. Tell me. Which two angles? No worries, Bonga. Awesome to have you. Oh, Nati, I'm very sorry. That's it. So it's an F. But which two angles then become corresponding? B1 and B2 are not. They're supplementary. Good. Okay, Kunzo says D. Good. Angle D, guys, remember, because we're talking about angles. Angle D and B. But it needs to be specific. Okay, that's the one I'm looking for. Angle B1. Not so much B2 or just B. It needs to be B1 and B. So the first thing we can write here is that angle B1 is equal to angle B. And our reason here is corresponding angle. And that's because BC is parallel to D. All right. Anybody, can anybody see any other F that could possibly help us find two sides that are equal or two angles that are equal? Anybody have or good. Okay, someone said ACE, and absolutely you were onto something there. Good. So we can see that angle E, here's my other F just in the opposite direction. C1 and E are also going to be. So for my second reason, I can go angle C1 is equal to angle E for the exact same reason. Okay. Then I can go corresponding angles. BC is parallel to DE. That's how we know that that's happening. All right. I need one more angle that is equal in order for this to be an angle similarity. Anybody can anybody see it? I think it's the easiest one. Oh, yes, they're co-interior, but they're not going to help us, Mawande. You're correct. C1 and E, we've already had. Who's Holy Spirit? I need to find out who Holy Spirit is. You need to give us your actual name, please, Holy Spirit. So I'll give you guys a hint. If you look at C and AE angle, just by looking at the name of the triangle, which angle is going to be common? Which angle is going to be common here? Good, no, not B and C. Think about it. A, B, E, B, C, and A, D. Remember, guys, we're talking about angles. So if you start saying AC, you're talking about side. And we're not looking for a side that fits relevo. Okay, relevo's caught on that those triangles have the angle A in common. Okay, and this is why, remember, guys, I was telling you, it's very important that we map out our triangle. So we need to go A, B, C, close. And then we start again at A, D, E. Close. So what angle do both of these triangles have in common? A. They have A in common. They have the angle A. So we can say here that angle A is common. We don't even need a reason for that. And then I can go, therefore, therefore, triangle ABC. Oh, hi, man. Is similar to triangle ABE. Before I even continue with the rest of the question, because I'm actually going to skip the rest of the question just a bit, can you guys give me a number out of 10? 1 being, I don't understand what just happened. 10 being, I'm with you, ma'am, I just wasn't 100% sure. Tell me, where are we sitting? Where are we sitting? All right, I'm seeing a couple of 10s and a 9. Okay, I'm seeing 9s, couple of 10s. Tail says 7. Thank you. Okay, great. I see 7s, I see 8s, I see 9s. Remember, guys, to be brutally honest, so I know where I'm starting. All right, Kama's at a 4, Stacey's at a 7, Future's at 100, and Lwazi at 5. Okay, that's fine, guys. That's fine. We're going to skip over this and we're going to do this quick example over here together. Why? Why? All right, let's try this one together, guys. Okay, remember, when we are proving similarity, we're always going to need 3 things because it's always angle, 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 or 3 sides of a triangle. All right, let's think about this one quickly. So it says here, prove that the following triangles are similar. So the first thing we're going to do, Takane says, ma'am, corresponding is F. How is it corresponding? CO, okay, F like this. Okay, if we draw an F like this, if this line is parallel to this one, Takane, that angle and that angle are equal. So that's how it's corresponding. And that's why we say the F is. Okay, I hope that makes sense. Okay, all right. First thing we're going to do, guys, is we're going to write, and then I'm going to go in triangle, and I need to make sure I map my triangles out correctly, guys. Okay, I'm going to go A, B, C, close. So I'm going to go in triangle A, B, C, and triangle. I'm not sure what that means. I need you to rephrase that for me, Remo. And triangle. Remember, I started at the top and then I went down. So I need to go P, Q, R, close bracket. Angle or triangle P, Q, R. We're going to close the bracket. All right. Somebody give me, let's look at our triangles. Remember, we need 3 things. 1, 2, 3. Okay, I need 3 of these. Okay. I need 3 of these. Where can we start? Good. They are both 90-degree angles. Good. We do have 2 90-degree angles. We've got that B and Q are equal to each other. So we can start. Okay, we can go. Angle B is equal to angle Q. Good. And my reason is that it's given. They've given it to us. They've told us by drawing those 2 triangles. They've told us. All right. What else do we know? Okay, Gamma says AB is parallel to PQ. No, because it doesn't say anything anywhere there. It doesn't even say that they're equal. They are 2 separate triangles. So we can't even do that. What can we do though? Has anybody figured it out? And I can tell you now, I'm going to skip a line over here. I'm going to go number 2 is going to come with 2 lines. Okay, and then number 3. Okay. I'm going to ask you guys, what about the interior angles of a triangle? What do we know? Well, Ushe, you are onto something. Ushe is definitely onto something. If you guys are in the chat, have a look. Have a look at what Ushe said. Ushe, so you're on point. C and P are in degrees. Good, they're in degrees here. That one is that one is that. But what begs the question is, what is A and what is R? That's the question we need to answer here. Okay. Good. Okay. But because we know that they don't match. They don't match. Because if we look at our triangle, A will match with P. A will match with P. So we know that P is 56 degrees. What is A? We don't know what A is. And we also know that B will match with Q. And we've proven that. Yes, we've written that in our proof. There. B and Q match. Okay. Last one that we need to look at is C needs to match with R. They need to be equal. So we know that if C is 34, we need to look for R, the angle. How do we figure out angles in a triangle? It's not going to be Pythagoras. Pythagoras would give us side, and that's not going to help us. That's not going to help us. How do we find that? Temilite, what do you think?
I'm not sure, but I think they add up to 180. That's what we know. But
Hey, absolutely, grade 7 word. The interior angles of a triangle will equal to 180. All right, we can do this together. Thank you, Timothy. That was not on point. I can go angle B plus angle C plus angle A needs to equal 180 degrees. And my reason is the interior angles of a triangle. Right, because they equal 180. Right, so I know that B is 90 degrees plus C, which is 34 degrees, plus A, which is what we're looking for, should be equal to 180 degrees. Okay, I'm going to skip one more line. Therefore, 180 calculator, guys, tell me what is A going to be equal to? A is going to equal to how much? Well done, Boitimelo. Well done. That's it. A is going to equal to 56 degrees. All right, so we know that A is equal to 56 degrees. We've done the work. I'm going to this. Can we use tan, cos, or sine for this type of question? Unfortunately, not, my sweetie. We can't. Because remember that sine, cos, and tan needs both angles and a side. Do we have angles and sides? If you look at the question that we've got, do we have angles and sides? No. We only have angles. The only time we could possibly use that is if, sorry, the only time we could possibly use that is if they've given us one of the sides. So let's say I got negative 56. No, it shouldn't be negative, because what should happen is the 34 should go over and become negative 34, and the 90 should go over and become minus 90, and that would give you 50, not negative. All right. If we do the same for R, we're going to figure out that R is equal to 34 degrees. So now we can make the deduction. Okay. We can then say that angle A is equal to angle P. Okay. And then you can even write here, proved above, because you just did it. You just proved it above. Okay. You've proved it above. Sinogute? No. Remember, congruency, we can only use congruency if the two triangles are identical. And unfortunately, this one is bigger than that one. Okay. They're not the same size. So we can't use congruency. We can only use similarity here. Okay, because that's what they're asking us for. They're asking us to prove that the triangles are similar. Okay. So this is number 2. Number 3, right? We can then say, by definition, because we know that A and P are equal and B and Q are equal, we can automatically say that angle C is equal to angle R. Okay. And the reason for that is interior angles of the triangle. Okay. As soon as we can prove that the other two sides are equal, it's automatic that the other two sides will be. Okay, so if I get to a proof, guys, and I can see that this one and that one is equal to this one and that one, by default, without us even having to do the mathematics behind it, we can already assume that the other two sides are going to be equal to each other. Okay, because those two are equal, and unfortunately, there's no triangle that comes in 190 degrees. They all come in 180 degrees. We can automatically assume that the other two sides are equal. Only then can I say, therefore, triangle ABC is similar to triangle PQR. What is my reason? Who can tell me? What is my reason? Remember, we have two reasons for similarity. What is the reason we're going to use here? That's it, Kushe. Yes, Mateo, I don't like that question mark at the end, but I agree with you. Yes, it's angle, angle, angle. We've used 3 different angles to prove it. Okay, angle, angle, angle. All right, good. So that's what we're going to be looking at here. All right, now let's look at this next one. I'm going to move it down a little bit. Look at all my stuff. Just like this one down a little. Okay. All right, now let's look at these 2 that they've given us over here. The instruction is prove that they are similar. All right, I'm going to ask you guys, this is a yes or no question. Are we going to be able to use angles? Can we use angles in this question to prove similarity? No, it's a big no, because they don't give us any of the angles. We don't know what's going on with the angles. We don't know which angle is what. No, we're not going to be able to use the angle. But we know that there are 2 ways that we can prove congruency. Not congruency, sorry, similarity. We know that we can prove that angles are equal, or we can prove that sides are in. So what we can do is, we can look at mapping these out in a way that's going to make sense to us. So we can start by saying, because we are proving, we can start by saying proof. Proof. I want somebody to give me the order in which I'm going to write my triangle. Does anybody know which way can I write triangle and triangle? Remember, the order needs to match. The order needs to match. Yes, Pama.
Ma'am, wouldn't you say triangle ABC?
Good. Triangle
and triangle PQR.
Good, good. I need the order to be correct. Loving it. Thank you. Thank you so much, Pama. That's exactly what I want. Excellent.
Period. Okay, ma'am.
Period. Yes, absolutely. 100% in that order. So now we know, because we're looking for our sides to be in proportion, guys, we're going to start with the first 2 letters. AB, tell me in the chat, guys, which side in our triangle will AB correspond to? AB will correspond to, have a look. I started this triangle, I started at A, B, C, close triangle. And this one I started at P, Q, R, close triangle. So AB will have to correspond with PQ, exactly, 100%. So AB is in proportion with PQ, and that is equal to, okay, if I have to take the other 2, that is equal to BC. Tell me, guys, which side does BC correspond to? BC corresponds to? Beautiful, that's it. It corresponds to QR. I use the last, okay, QR, which is equal to the first and the last. Now we have to take the first and the last. Now we have to go AC. Which side does AC correspond to, guys? AC corresponds to? Beautiful, that's it. It corresponds to P. Excellent. But because we're proving this, we need to make sure that these sides that we're mentioning are actually correct. Okay, so I'm going to replace the sides with numbers. Okay, Peter says, can we use ACPQ, and PR as hypotenuse? No, we cannot. No, Keisha, we cannot. The fundamental thing for hypotenuse is that. It's that right angled triangle. And they haven't told us that it's a right angled triangle. Therefore, we can't just assume that it is. Okay, we can't do that. All right, hi, Kama.
Hi, ma'am.
Hello, Miss
Sorry,
Judy.
I was just I was just going to ask if you guys have done vertical trig graphs yet.
No, not yet.
Oh, okay, perfect. Never mind then.
Sure. All right. Okay. So I saw somebody asking why in this order. The order makes practical sense from a looking at its standpoint. That's why we chose this order. We could choose another order, but that's just going to create more work for us in the end. Because you can already kind of see where the triangles are going in terms of similarity. If you choose that you're going to pair PR with AB, that's going to make your life very difficult because the correspondence isn't going to be. So look at the way that you would look at it and say, I think these sides are in proportion and these sides are in proportion. All right, everybody's going to grab their calculator. We're going to go AB is equal to 7 over PQ, which is 2,8. And that must be the same number. It must be equal to BC, which is 9,5 over QR, which is 3,8. And that is equal to AC, which is 8,2 over PR, which is 3,8. Now you need to punch these into your calculator and see what you get for each of them. So go to your calculator and type in 7 divided by 2,8. Does it give you 5,2? Okay, it gives us 5,2. Now go to the next one. Go to 9,5 divided by 3,8. Does that also give us 5 over 2? Yes. Which should be equal to, I guess you guys know where this is going. 8,2 divided by 3,28 should in essence also give us 5. Now, because all the sides give us the same proportion, we can then say, therefore, triangle ABC is similar to triangle PQR. And Mawande, it will not be side, 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 because when you say side, 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 what you're telling me is that my sides are equal. No, 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 no. You have to write sides in proportion. You have to write sides or corresponding sides. Here I am lying to you that you need to write corresponding sides in proportion. Okay. Mateo says, ma'am, when do we know to cross multiply? Mateo, if they didn't give you an answer for this side, if they said to you, find AC, you're looking for the side, therefore then you must cross. So if they don't give you the side, then you must cross multiply to find the side. Okay, I hope that makes sense. All right, let's do a quick check-in again. How are we feeling about this? From 1 to 10? From 1 to 10, how are we feeling? Luigi-Melo's at a 10, Mateo's still at a 7. Oh, prop is proportion. Sorry, my sweetie, I'm making them shorter, proportion. Thomas at a 5, oh my goodness. Okay, we need to get a lot higher than that. I'm seeing Lunico's at a 7, Mwande at an 8, 9, I'm seeing 6s. All right, guys. 100 all the way. I love it. Okay, I see you. I see you. Excellent. All right. So I'm not mad at some of your marks. Those of you who are at a 5 and a 6, remember this is the second time we're going through this. We did this on Wednesday as well. Okay, we looked at similar triangles. Yes, my sweetie, what's up?
Hi, sorry, I'm like a little blind and I tried zooming in like the corner. Does that say prop or prep?
Prop. P-R-O-P.
Thank you so much.
All right. Okay. Not proportion. Proportion, not proportion. Okay. Yes. Patient says, ma'am, can I ask, we get a chance to write a test or something here? We have quizzes every Wednesday. So on Wednesday, you'll have a chance to do your quiz. Boitumelo, I see your hand up, my sweetie. You need to connect to your mic. So you need to go to your settings and connect your mic. Otherwise, I won't be able to mute you. Okay. All right. And patient, the quizzes are not for like any formal marks that's going to go on a report and that's going to affect your your grade average at school, none of that. It's for you too. It's for you
But
to
your mom will receive your result though.
yes, your parents will receive your result. Haley says, ma'am, is this lesson also going to be on the website? Yes. So if not tomorrow, then it will be up on Wednesday. Definitely by Wednesday.
After
All right.
24 hours.
After 24 to 48 hours. Melo just went away as I was about to enter. Or her or him. There we go. Hi, Melo. What's up?
Hi, Mom. How are you?
I'm good. Thank you. How are you doing?
I'm good. Mom, I just had a question. Have you started with quadratic equations yet? Because today's my first day as well.
Yes. So we have already done quadratic equations.
Okay.
We'll find the recording on the website. Like just go to all the classes we have now, look underneath them because we've already done equations and inequalities and it's done.
Okay. Okay. Thank you, Mom.
You're welcome. Nolazi said, I got 4 out of 10 on the quiz. My sweetie, it was such an easy quiz. Try it again. Do it again. Don't just do it once. Okay.
Yeah.
Michael says, is this lesson going to be in video form? Yes. Okay. All right. Okay. So I'm going to introduce what we're going to be looking at on Wednesday, which is actually the crux of grade 10 mathematics. Hi, Tembelito.
Ma'am, I hope you're fine. I wanted to ask, so if we don't get like the mark that we like on the quiz, we can redo it again.
Absolutely. Yes. 100%.
All right, thank you, ma'am.
It's not there for marks. We're not going to mark it and send a report and say, you failed Watobe. It's for you to learn. So do it again and again. Okay. Patience, what's up? Hi, Patience. Yes, redo it, Puseleto. Hi, Patience. Oh no, you read it and then read it again. What happened? Thank you for that, teacher. Nels Kama says, ma'am, do I have to do every quiz until now? No, take your time. All right. Take your time, look at the lessons, make sure you're understanding what's happening, and then do a quiz. You don't have to do every single one. Okay. All right. Here's what we're actually supposed to be looking at. Okay. Oh, that's okay, my sweetie. Remember, Haley, we have recorded these. So if you missed the last few minutes, you can just go watch the recording in the last few minutes. Okay. Thanks for joining us. Okay.
Michael was just finding that out today, that you can redo the what?
Okay. Give me a second. All right, guys. Cheers, Haley. Michael, you've been with us since January, my dude. The fact that you don't know is very shocking. All right. So we're going to be looking at quadrilaterals, guys. Oh, Bunte, that's okay. Welcome, Bunte. That's okay, my sweetie. Okay. For those of you asking about, ma'am, I'm new here. I want to ask, are we doing trigonometry? We've already done it. Okay. We've already done it. And all the recordings are on the website. All the quizzes are also on the website. Okay. Yes, Remo.
Ma'am, I
Yes.
quickly just wanted to ask if you have already done the functions, topic on functions.
No, we haven't. That's what's coming next. Okay.
Thank you, ma'am.
All right. Excellent. Okay, guys. So we learn about quadrilaterals. And the fun and funny thing about quadrilaterals is that if you don't know the rules of your quadrilateral, you're basically you're screwed. Like it's not gonna help you to deal with it. Like is it called a brain break? What is that? What a brain? A brain? I don't even know how to pronounce that word, Funaka. I don't know what is that. No,
What is it?
I'm kidding, guys. You know,
Like an
the amount of
animal?
work we need to get through, it's quite difficult for us to have brain breaks. I'm waiting for a moment where we can slow down so that I can actually put a brain break in there, guys. I'm very sorry. This grade 10 is so demanding. I'm very sorry. All right, okay. So what I put on the table, guys, I'm so sorry. Okay, I think I need to make a mental note. Brain break on Wednesday. Okay. All right. So we need to know the properties of quadrilaterals in order to use them in our mathematics and in order to prove for them. So if I give you a shape and I say to you, this is a shape, prove to me that this shape is a rectangle. Now, you need to know that a rectangle has all corners 90 degrees. Okay. You need to know that this side is equal to that side, and this side is equal to that side. And you also need to know that this side is parallel to that one, and this side is parallel. All right. So those are the types of rules that we need to know about our quadrilaterals in order to answer questions. All right. So we're quickly going to go through the rules of quadrilaterals. That's all we're going to do today. And that's the end of the lesson for today. I know it's been a lot, but we're quickly going to have a look at it. Oh, look at me just being practicing that I am today. All right. Yes, Remo.
Ma'am, I'm sorry to disturb. I just wanted to ask that this table, is it possible for us to print it for ourselves?
Yes. Okay. So what I normally do, my sweetie, is before the lesson ends, I give you guys a chance to take a screenshot. So you can take a screenshot of this. I've actually just pulled this off of Google, so it's not even that deep. If you just Google properties of quadrilaterals, I'm pretty sure this very table will show up. So you don't even have to worry too much about it. Okay. All right. So we're going to be looking at a square. Okay. Mama is really putting me on the spot.
Ma'am, can you scroll down?
Would you like me to scroll down? All right, there we go.
Yes, ma'am.
Is that helping?
Thank you, ma'am.
All right, Ms. Biddy. Excellent. All right. Okay. So I'm just going to focus on a couple of things. I'm going to go over them very quickly, and we need to focus on these because those are very important. All right. We need to know that our square always has 90-degree angles on the side. And if that is ever the case, that this has 90 degrees, that's going to mean something for my diagonal. First, let me ask, what does it mean about my sides? What do we know about the sides of any square, guys? What do we know about the sides of any square? Yes, no, lovely. Good. All right. Yes, they're all equal. So all the sides are equal. Now, if all the sides are equal, and I know that each of these sides is 90 degrees, each of my corners are 90 degrees. Hannah Lovely.
Hi, ma'am. Ma'am was asking if you haven't forgotten about me.
No, I haven't. I have not forgotten about you. Okay. We were going to have a conversation now. All right. Just leave your hand up so I don't forget you. Okay, good. So we know that all the sides are equal. What's going to happen, guys, if I put a diagonal right in between? What do I see here? And what do I see here? What do I see if there's a diagonal in between? So we see two triangles, RHS, that's correct. Okay, we're going to see two congruent triangles that can be proven by using RHS. And you see why the congruence was important. Okay, so the congruence is something that we need to remember in these. Also, okay, I know that if I do this and if I do this, we call these two lines diagonal, right? These two diagonals also create a 90-degree angle here in the middle. Okay, so those are the important things that we need to find out and we need to know about these triangles. Well, I'm saying triangles, about these quadrilaterals, because those are the things that are going to help us to figure out whether our square is in fact a square. Okay, so we know that these diagonals, they actually give us 360 degree 300 revolution right in the middle, and each of those is 90 degrees going in. So those are the things that we need to remember. Even if we look at a rectangle, guys, I know that this corner over here is 90 degrees. And if I draw a diagonal in, what do I know about this side and that side? What am I looking at over there? Says, ma'am, does the 90 form on all 4 triangles? Yes, it does. In that case, it does. Okay. Yes, in the case of the square, but only in the square. Michael's like, what do I notice about them? They're both long, ma'am. Something else. Yes, good. They're equal. Yes, Vijay, that's what I'm looking for. That they're exactly equal, which means that they're congruent. And we know that we know about the type of congruency that we can use here because there's an RHS. We can prove RHS. Also, if I have to prove, or if I have to figure out the length of this side, how would I possibly do that? If I had to figure out the length of this long side, what am I looking at? Stephen, you are correct. What can I possibly use? Yes, that's it, Mateo. That's it. We can use Pythagoras to find it. So all of these properties of these quadrilaterals, remember quadri means 4, all of the properties of these quadrilaterals need to be put into practice when it comes to these. All right. Unfortunately for a rectangle, the diagonals do not create 90-degree angles in the middle. It will depend on how the rectangle is shaped to the side, the diagonal. That's beside the point. All right. So we also need to look at that. Right. We also know that each side of a triangle, of a rectangle, is equal. And we should also know that each of the corresponding sides are I almost said perpendicular, parallel to each other. Okay. So all of these things are things that we're going to have to remember. And just like I was just showing you guys, congruent triangles, similar triangles, they're going to come into play in this. Yes, Michael, they're all isosceles. Beautiful. Michael just saw that because this angle and this angle will be equal. This angle and this angle will be equal. Therefore, these basically. Yeah. So there are a lot of things about these quadrilaterals that we need to know, guys, and we're going to be using them in order to look into that. But we're going to go through that in next week's lesson. However, I am going to give you guys homework. I'm giving everybody homework today. Okay, thank you for the poll. Today's homework is learn the properties of quad. That is your homework. Okay, that's what you're going to go do for me before Wednesday. You're going to go learn the properties of quadrilateral. Agree. Right. Give me a thumbs up in the chat. Does everybody know what the homework is?